My name's Kendra Short. I'm affiliated with the Jet Propulsion Laboratory and the California Institute of Technology. All right, my NIAC project is called Printable Spacecraft, Flexible Electronic Platforms for NASA Missions. And it's based on printed electronics to create end-to-end functional spacecraft. When you think of electronics, you think of circuit boards that you would find in your VCR or something like that, which has microprocessors and silicon chips and things like that. Printed electronics use the same building blocks that make up those types of electronics, such as transistors and logic circuits and things like that. But it's printed on a flexible surface. It could be plastic, it could be glass, it could be paper, it could be Kapton, using a liquid ink that performs a certain function, whether it be a conductive function or a semiconductor function, or even photovoltaic sensitive inks. So if you look at all of those functions that a typical spacecraft has to perform, and you imagine doing those functions with purely printed circuits, that's what I mean by an end-to-end spacecraft. So what becomes your spacecraft is essentially the flexible sheet of paper that you've now printed all of these circuits on. There is no structure. There is nothing other than the two-dimensional sheet. Printed spacecraft would be envisioned more as scientific platforms. On a surface network, you could imagine a series of lander spacecraft measuring different items of scientific interest, like the temperature of a planet, the pressure, atmospheric pressure of that planet. And some of the advantages of a printed spacecraft would be taking advantage of the unique properties of that thin substrate material in terms of flexibility. It allows you to store the spacecraft in different ways. You could roll up your spacecraft and unroll it on the surface of the planet. Also, there's mass and volume advantages. Since they're thin sheets of paper, basically, it doesn't take very much mass to get the function that you're talking about. And so it enables making a large number of a particular type of platform. I can package 1,000 of those sheets of paper into a traditional aeroshell and deliver it to the surface of Mars. The benefit of being part of NIAC is, first of all, they're willing to accept some crazy ideas and allow you the flexibility to investigate whether there's really some merit to the idea. And that's what we were able to do in phase one. Coming out of phase one, we are able to invest in demonstrating this technology without a particular mission that we're ready to apply this to. A lot of times we do focused technology investments at NASA that need to meet a certain functional requirement of a mission that's on the books. NIAC allows us to be a little bit broader in terms of our application than a particular mission, and look at some of these cross-cutting technologies that can have multiple applications in lots of different programs and lots of different systems.